Greetings of the day. I'm Tushara from CSE third year. I'm here to present a project on Airbnb price prediction using Python under the guidelines of Dr. Anusha. So I'll be explaining this now. Here we use a NumPy. It is the library for numerical computations in Python. It provides the support for arrays, mathematical operations, linear algebra, etc. And Pandas is used for data manipulation and analysis. It provides data frames and series like series data structure. Matplot library is used for data visualization. And this line, it reads the CSV file named ABNYC 2019.csv from our Google Drive path. And it uses Panda to read and to load the data into data frames called my data. So this shows the first five rows of the data set. This my data shows the first five rows of the data set. It returns the data types of each column in your data frames of my data. Here this checks if the column last review exists in the data frame. This last review column which exists in the data frame. It's a good safety check to avoid errors if the column is missing. And if last review doesn't exist, this line converts it from a string object to data time format. This allows you to perform time-based operations like filtering by data and extracting year or month sorting by date, etc. If the column is missing, see here, if the column is missing, this prints a message instead of causing an error. So it doesn't collapse the code. And here print my data types. This displays the updated data types. Yeah. From here, these are the updated data types. This here the Seaborn, it imports Seaborn. It is a visualization library based on Matplot library, and it is also good for statistical plots. This selects only numerical features like numerical columns from the data frames, and it calculates the correlation matrix between numerical features. It prepares an 18 to 8 figure for the heat map. It creates a mask to hide the upper triangle of the correlation matrix to avoid duplicate values. And it also plots the correlation heat map showing how strongly numerical variables are related. Let's run this. Yeah, you can see here. So here now it sets up 10 into 10 square plotting canvas. So the bars and labels have boom. And here SNS bar plot, it plots the average price of each neighborhood group. By default, Seaborn computes the mean of price within each category and draws a bar. Let's run this. Here it sets up 10 into 6 inch canvas for the plot. The SNS plot, it plots each listing longitude versus latitude and coloring points by neighborhood group to show geographic clustering by boroughs. Here the categorize function, it is used to bucket each price into a low, medium or high. It up And here it apply indicates it converts every listing price into category and the value underscore counts. It counts how many listing fall in each bucket and plot. It draws a bar chart of those counts showing the distribution of price categories. Yes. Maybe we can see here. So here my data name, it replaces any missing, yeah, it replaces any missing names values with an empty string, ensuring no nulls remain. And this the display confirms the count of nulls is same is now 0. Yeah, you can see it is 0, is as same as the before. Now here this function remove punctuation distill special care. It uses a regular expression to remove all non-alphabetical characters like punctuations, digits, specific symbols, and it converts the text of lowercase for consistency and applies this function to each entry in the name column, creating a new column, clean underscore name. And here my data, like name, clean name, it shows the original and cleaned name side by side for comparison. Yeah, you can see it is used, it shows here for comparison. Here pip install upgrade LightGBM. It uses pip Python, which is a Python package installer to install or upgrade the LightGBM library in your collab environment. We got an error. Let's fix this error. Yeah. And the LightGBM library in your collab environment, it is a high performance gradient boosting framework, which is commonly used for building fast and accurate decision tree models. And here this LGBM classifies for the classification model and test and train test to split various metrics for evolution and random oversampler to balance classes. Yeah, it got installed. Uh, it buckets listing into it buckets listing into expensive. If the price is greater than 300, then it buckets listings into expensive. If it is 0, then it buckets into cheap and shows class counts. It shows here it shows precision recall F1 for each class plus overall accuracy and recall for the expensive class. Yeah. Here drops here. Now let's run this. Yeah, you can see the precision recall and F1 score and support. Now this data drop the targets and columns from the my data frame. Here you can see it. Where axis equals to 1, it specifies we are dropping columns, not rows. In place is it truly modifies the original my data frames directly without needing to assign it back to a new variable. You can see here this follows the again the first 5 rows. Now here label encoding, which converts categorical values into numeric values. For neighborhood, Here it encodes each unique neighborhood group like Manhattan, Brooklyn to a number. And for neighborhood, it encodes each unique neighborhood in the dataset of a number. Here, encodes dataset of a number. And for room type, it encodes here. And for room type, it encodes different room types like entire room or private room to numeric values. And here my data shows the first 5 rows of the dataset after categorical columns have been label encoded. You can see the output here. Now coming to the regression model, linear regression. It is a linear regression. First, it filters out rows with 0 or negative values in price and availability of 365. And this X shows features used to predict the price, and Y shows target variable transformed with logarithmic scaling to reduce noise and make it more normally distributed. And now it splits the data into training and testing sets, 80% for training and 20% for testing. Trains linear regression model on the training data. Here the mean square error is calculated. It shows, see here the mean square error is calculated. It shows how well the model predicts, and lower is better. And R score, the percentage indicates how much variance in the target variable price is explained by the model. High for R score, higher is better, and for mean square error, lower is better. And coming to mean absolute error, it measures the average absolute error between predicted and actual values, and here the lower is better. Finally, the output shows the model's performance matrices for price prediction after log transformation. So you can see the mean square error, R2, and mean absolute error. Now coming to decision tree regressor, it initializes a decision tree regressor with a with a square error criterion, a maximum depth of 3 to prevent overfitting. So we need to prevent here overfitting, and fixed random states for reproducibility. So first, the decision tree regressor to the training data like X train and Y train. Here, it makes prediction on test on X test. So here the prediction takes place. It measures the relative absolute deviation of predictions compared to actual values. It is helpful for understanding how the predictions are distributed. Now here the mean square error, it shows well like as same as a linear regressor. For mean square, lower is better, and for R square, higher is better, and for mean absolute error, the lower is better. And this curve evaluates decision tree regressor and provides multiple metrics for assessing its performance in predicting Airbnb listing prices. Let me run the code. Yeah, you can find here mean squared error, mean absolute error, and R2 score. Now here my data dot head, it displays first 5 rows of your current my data data frame. Yeah. No, here pip install FuzzyWuzzy. It uses to it is a package. Yes, let us install this. Yeah, it got installed. This FuzzyWuzzy provides function for fuzzy string matching, example ratio or partial ratio, which helps compare and high score and how similar two strings are, and useful for task deduplication or matching noisy text data. Now here it imports a FuzzyWuzzy string matching function. It takes input as a title, like example village. Let us take an example title as a village. Now the title is compared to my data like final name column, and returns the closest match based on the fuzzy string matching. Now it finds the closest match to village in the dataset and stores in the title. See here, the village is stored in the title from the dataset. that is most similar to the input. Examples. Yeah, you can see here a village, Hamel, New York. It is so this project is all about a New York Airbnb price predictions. And I can conclude that this project is focused on predicting Airbnb prices using data preprocessing and exploratory analysis and models. So the data cleaning and EDA modeling, fuzzy matching are involved in this, where data cleaning, like handle it as a handle the missing values, encoded categorical variables, and transform the target variable using a logarithmic scale. And EDA, it is a visualizer relationships between features like a neighborhood, room type, and price. And modeling, it built linear regressor and decision tree model for price prediction, evaluating RMSE, R square, and MAE. And in the linear regressor and in decision tree, the decision tree offers better interpretability. The project showed that factors like neighborhood and room type is significantly impact price with the room. For further improvements, are using advanced models and feature engineering. So this is our project, and thank you.